Okay, people, are you able to hear me?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So just we'll start off the class. Okay, let the others join later. Tell me what are the topics that we discussed yesterday? Just name the topic.
Transducer.
So what are transducers?
Convert one form of energy to another form.
So convert one form of energy to another form. If it is being converted to electrical form, means what is the name of the transducer?
Electrical transducer.
Electrical transducer. Suppose if it is converted to any other form, means it will be
A
called as non-electrical
non-electrical.
transducer. Apart from this category, what are the other ways in which you can do the classification of a transducer? There are so
Active,
many
passive.
possibilities. Active, passive. What is the meaning of active and passive transducer?
Example is photovoltaic cell, photoelectric.
So, what is the meaning? Examples are okay, but what is the meaning
It,
of
its own
active and passive?
energy it will create. Its own energy.
So, the transducers that use their own energy to extract that conversion, those are called as active transducers. Example is piezoelectric transducer. Suppose on the other hand, if the transducer is making use of external voltage source, then it will be called as
Passive.
passive transducer. Mostly majority of the transducers are passive category only. So this is another classification. Electrical, non-electrical, active, passive, and then one more thing, two more classifications are also there. Resistive, capacitive, inductive. Okay, depending upon what effect is being used to do that conversion, we are also having another category that is called as resistive, capacitive, and inductive. And apart from this three categorization, two more categorizations are the direct transducer and indirect transducer, and one more category that is primary transducer and secondary transducer. Okay, suppose if you are having a microphone and loudspeaker combination, then it always work in combo. Okay, so one will be acting like a primary transducer and the other one will be acting like a secondary transducer. So that is the meaning of this thing. So that I have left out yesterday, so I am just trying to cover it up. Plus, what are the particular type of transducer we discussed yesterday? Two
LVDT and
transducers.
LVDT and
One
mic one.
LVDT and capacitive transducer we discussed yesterday. So capacitive transducer works on the effect of capacitance. It will be having one fixed plate, static plate and a diaphragm. So depending upon the applied force or pressure, the diaphragm moves. So it will act like a capacitor plate which will be converting the force into an equivalent frequency signal, that is capacitance effect. Okay, distance between the two plates is changed, so the area is changed, so it will automatically change the capacitance. So this is how capacitive transducer works that we have discussed yesterday. Plus one inductive type of transducer also we discussed. What is the name of that inductive transducer we discussed?
LVDT.
LVDT. So what does it measure? LVDT, linear variable displacement
Linear
transducer.
variable
What does it measure?
displacement transducer.
So what will be the constructional detail for an
Displacement.
LVDT?
It will check displacement.
Yes, it will convert the displacement again in terms of force. Only you are having displacement. So whenever you are going to apply a force to some material, then it will get displaced. So you are going to measure force only here in terms of output voltage. Suppose if the core is getting not displaced, means it is in null position, so the output voltage will be zero. Suppose if it is moved in upward position or downward position, accordingly the output voltage will be either positive or negative, with the help of which you will be determining whether the core is displaced and in what direction it is displaced. So that is linear variable displacement transducer. So one capacitive transducer and one inductive transducer we discussed yesterday. So today the remaining thing we are going to discuss about, that is a transducer that works on the effect of resistance. Okay, how it measures the physical variable in with the help of that resistive effect we are going to discuss. So many types of transducer are available which are actually resistive. Simple type is potentiometer. I think potentiometer all must have heard. So what is a potentiometer? What does it do? What does it do,
Measures the
potentiometer?
potential difference.
Potential difference means,
Voltage.
wait, let me check. The other system is not getting connected. Let me check it. Okay, so today we will be discussing the resistive type of transducers. First, we will discuss strain gauge, potentiometer. All these are coming under resistive category of transducers. So first, let us discuss strain gauge. So the name is strain gauge. So what will it convert? Strain gauge. What will it convert? I think I have told you about strain gauge in the lab class. What do you know about, or what have you learned about strain gauge?
Strain is force upon area.
Strain means when you are applying force or pressure onto a particular element, a metal conductor you assume. Okay, so you are applying some force or pressure onto a metal conductor. So it will be getting stretched or compressed. Okay, so it will be subjected to strain or stress. It will be either subjected to compression or stretching. Okay, suppose for example, if you assume that metal conductor is being stretched. Okay, so what will happen to the length? Consider a fine wire of resistance, okay, conducting wire, okay. Suppose if you are subjecting it to stretching, okay, what will happen to the wire? General wire you assume. Suppose for example here you are
It will
having a
get
fine resistive wire. Suppose if you are
it will get
subjecting this,
thinner.
what will happen?
It will get thinner.
You are subjecting it to stretching, okay, so what will happen to the wire? It will get uh, what will happen to its length actually?
Increase.
Yes, length will increase. Okay, length will increase. And you know there is a particular formula for R, no? What is the formula for R? R is equal to rho L divided by A. Do you know the formula? Rho L by A.
Yes, ma'am. Resistance.
Yes. So L and A are what parameters? R is resistance. Rho is specific resistance. What about L and A?
Length and area.
Length and area. So if you are going to subject that wire to stretching, it will increase in its length. So if length is increasing, what will happen to the resistance? Resistance will also increase. Okay, resistance will also increase. So if resistance is increasing, the thing is original length is L. So it is subjected to stretching, so it will add up its length to del L. Small increment in length will happen. So with this, you will also have R plus del R. That means a small addition of resistance is happening to the original value. So with the subjugation of that material to stretching, the length increases. That is, dimensional changes happen, and accordingly, you will be having resistivity changes also. So, two formula is important here. I will tell you the formula. Okay, so formula how to learn. Alright, I told you there will be a change in length. So strain is given by one formula. The original length is L, the changed length is del L. So this formula goes for what parameter?
Length.
Original length is L. It is now subjected to stretching. So it will have increment in length. That change in length is del L. So that is equivalent to what? The ratio of change in length to the original length is called as what?
Strain.
Strain. Okay, that is called a strain. And there is one more factor that is commonly asked in MCQs. What is the formula for gauge factor and sensitivity? Okay, gauge factor sensitivity. That is given by G, which is equivalent to del R by R divided by del L by L. Okay, so this del L by L is equivalent to what factor?
Stress.
It is strain. Okay, so del R by R divided by strain, that is equivalent to what is the name of that factor? Gauge factor or
Gauge factor.
sensitivity. Okay, gauge factor or sensitivity. So what is the formula for gauge factor?
Del R by R divided by del del L by del.
Okay, so the general meaning of strain gauge you understood or not? Suppose if you are having a metal conductor and you are subjecting it to tension or compression, suppose if it is getting stretched means it will be having its change in length. Okay, so original length if you are assuming it to be L, now the change in length will be L plus del L. So if there is a change in length, you know there is a formula for resistance which is equivalent to rho L by A. So L increases means automatically there will be a corresponding increase in resistance. So original resistance will also be subjected to some small amount of incremental change. Okay, and two important formulae how to remember: the formula for strain and the formula for gauge factor or sensitivity. So what is the formula for strain? Strain is given by del L by L. Gauge factor of sensitivity is given by del R by R divided by strain formula. Okay. Now, with this being over, let us discuss the different types of strain gauge. So, there are two types of strain gauge actually. One is bonded and the other one is unbonded. Okay, unbonded strain gauge and bonded strain gauge that we will discuss now. Okay, so this diagram shows your bonded one. Okay, I will tell you why it is called as bonded. Now, if you see to the diagram, there is a element that is called as base or carrier. Okay, that base or carrier will be made up of bakelite. Okay, bakelite, and to that base you are going to cement a fine resistance wire. Okay, this is your grid wire of fine resistance. The wire's diameter will be usually 25 micrometer. So this fine resistance of wire you are going to cement onto a base which is usually made up of bakelite. Okay, and over this combination you are going to place a small sheet of material so that you will be able to protect this arrangement. Okay, and this whole strain gauge will be fixed with the help of an adhesive to a material which you are going to study. Okay, so that material may be any material whose strain you want to measure. Okay, you will be applying force onto that material and it will be subjected to stress or strain, and you want to measure that strain or deformation in terms of resistive effect. Okay, so that is why you are using a strain gauge here, and this type is called as bonded. Okay, why it is called as bonded is because the strain gauge with the help of the adhesive will be connected or attached to that material with whose strain you want to study. Okay, understood the meaning of bonded strain gauge?
Yes, ma'am.
Why that is called as bonded? What can you say about the constructional details of a bonded strain gauge? I'll draw it again. Okay, so you want to study one material. Okay, the strain of one particular material you want to study. For that purpose only you are going to use a strain gauge, which is bonded one. So you are going to have a base or carrier which is made up of bakelite. Over this you are going to cement some wire. Okay, some wire with the terminal markings. Alright, this is your fine resistive wire whose diameter will be 25 micrometer. That will be cemented onto this bakelite base. Okay, and over it you will be having some covering. Okay, everything will be covered by some protective material so that the whole arrangement does not get mechanically damaged. And under it, okay, under it you will be keeping the material that you are going to study, whose strain you want to study, that you are going to keep it under. With the help of an adhesive you will bond. Okay, understood the constructional detail why it is called as bonded strain gauge, yes or no? Again I am asking you the question, why is it called as a bonded strain gauge? If you do not understand that concept, you cannot go to an unbonded strain gauge. Why is it called as a bonded strain gauge? If you are keeping silent from your side, I will also keep silent from my side, and classes will be over, and there will be nothing good coming out of it.
Ma'am, once you repeat it, ma'am.
Why is this called as bonded strain gauge? So you want me to repeat the entire constructional detail again, third time? Is it so? Okay, anyways, I'm doing it
Yes,
again.
ma'am.
Yes, ma'am.
So there will be a base, okay? There will be a base which is made up of bakelites. Over this, you are going to keep a fine resistive wire. Okay, this is your resistive wire whose diameter will be 25 micrometer. You are going to cement it, fix it on the base. Okay, then this whole thing, this is called as a bonded strain gauge. Okay, under this, okay, underneath this arrangement, you are going to keep the material that you are going to study. That material strain only you want to measure. Okay, so that material you are going to keep it underneath. You will be fixing a top with an adhesive. You will be bonding it the material with the help of an adhesive. Adhesive means like a gum. Okay, now you understood, huh?
Yes, ma'am.
Yes, ma'am. That is why it is called
That
bonded.
is why they are called as bonded strain gauge. Okay, and next thing is when the material is subjected to strain, that strain will be transferred via the base to the resistive wire. Okay, so that resistive wire will be undergoing two dimensional changes. Accordingly, you will be able to have a change in resistance. That resistance will be measured by a bridge that is called a Wheatstone bridge. Wheatstone bridge is commonly used for measuring resistance. It is a DC bridge. So using that, you will be measuring resistance. Okay, understood how it is done? How the input force strain is being converted into a resistance?
Yes, ma'am.
Okay. Again, that material that you are keeping underneath, that will be strained. Okay, that strain will be transferred via this base onto this fine resistive wire, grid wire, whose resistance will change R plus del R. Okay, because of L plus del L. So that will be measured by one bridge. The name of the bridge is Wheatstone bridge. Okay, and this strain gauge is called as what type of strain gauge?
Bonded strain gauge.
Bonded
Bonded
strain
strain
gauge.
gauge.
Okay, so many different shapes are possible. Okay, that earlier one that you discussed is star gauge. This will be called as wire gauge. Okay, this will be called as wire gauge, but the arrangement is always the same. Again, you will be having the same carrier base made up of bakelite, over which you will be having a fine resistive wire. Okay, and underneath it you will be keeping the material that you are going to study, and which is being subjected to strain. That strain will be transferred to this resistance, because of which the resistance will be changed, and it will be measured by a bridge that is called a Wheatstone bridge. Okay, this is also a bonded one or an unbonded one?
Bonded.
Bonded. Okay, now we'll see to what is the difference that it makes with an unbonded strain gauge. So this picture shows your unbonded strain gauge. It's not bonded one. This is also a bonded strain gauge only. So you can see here, this is corresponding to bonded strain gauge. That is your wire gauge. All right. Okay. And this is your bonded wire gauge that is connected to one bridge. Okay. This bridge is called as what bridge? This is a DC
Wheatstone
bridge.
bridge.
Wheatstone bridge. This is specifically meant for measuring resistance only. Okay, so this is how the input strain is being converted into a resistive effect. Okay, all this is about what type of strain gauge again?
Bonded strain.
Bonded. Okay, and you can see for yourself here. Suppose if that gauge is subjected to lateral forces, that is when force is being applied, there will be either compression or tension. So when there is a tension means what is happening to the resistance? Resistance will increase or not increase?
Increase.
Increase. Suppose if it is subjected to compression means resistance will decrease. Okay, and this resistance will be measured by using this Wheatstone bridge. That's all. Okay. Now, next thing is you need to discuss about an unbonded type of strain gauge. This is your unbonded strain gauge. Alright. The difference here is the material under study will not be bonded. Okay, with the help of an adhesive, it will not be bonded to the strain gauge element. That is why it is called as an unbonded strain gauge. Okay, and as you can see from this diagram, the input is the force. Okay, and that force will be applied to the frames. Two frames are there, P frame and Q frame, both are mobile. Okay, they will be sliding across each other. Okay, so when force you are going to apply to these two mobile frames which are sliding against each other, on the top you are having four number of insulated pins, and between these pins you are connecting what here? This is what actually. What is that? This one. That is nothing but again fine resistance wire. Okay, so this is connected between all the four insulated pins. So when the force is being applied, what will happen? These two frames will move with respect to each other, because of which what will happen to the resistance of the wire? Just now I told you the principle of strain gauge. What will happen? You are going to apply the force. With respect to the application of the force, the material under study will be subjected to either tension or compression. So with the help of which, what will happen to the length and area? What will happen to the dimension, that is length and area?
Length will increase and resistance will increase.
Yes, that resistance of that wire will be increasing, and this is called as unbonded strain gauge because of what particular reason? Why is this an unbonded strain gauge and the earlier one's bonded strain gauge?
There is no adhesive.
Yes, without the adhesive, there is no bonding between the material of study and the strain gauge. Okay, so that is why these are different, but the principle of operation and all are same. Okay, again you will be using the Wheatstone bridge to measure the resistance only. So this is also called as a displacement transducer. Why? Why is this also called as a displacement transducer? LVDT is another good example of displacement transducer. Strain gauge is also a displacement transducer. Why? And tell me whether this is an active category or a passive category. What type of transducer is a strain gauge? Active or passive?
Passive.
Passive only. Okay. And then tell me whether it is a displacement transducer or not. What is displacement? From yesterday, I'm keeping on telling the word displacement. What is displacement? How the displacement will occur? How the displacement will occur? So when somebody is pushing you by force, manual force, what will happen to you?
We will move from our place.
Yes, you will move from one position to another position. That amount of movement is called as displacement. Okay. So this strain gauge can also be called as a displacement transducer or not. Unbonded type.
Yes, ma'am.
Yes,
Yes, ma'am.
unbonded type. There are two frames that you are having, which are moving or sliding across each other. So this can also come under a displacement transducer. It is also a passive transducer. Okay. Then next comes your potentiometer. You must answer for potentiometer because you might have some idea. Now this shows your applications of strain gauge. So what are the things that it is used to measure? You can measure vibration, you can measure stress, you can measure torque, you can measure bending and deflection measurement, you can measure compression and tension, you can measure strain. For all these you need to have a strain gauge. Okay. Then comes your potentiometer. So what do you know about potentiometer? I think almost all of you must have seen a potentiometer, how it looks like. So what is a potentiometer? What is a potentiometer? What in general, POT, what are potentiometer? It is a resistive transducer or not a resistive transducer? In today's class, we are discussing what type of transducer, capacitive or inductive or resistive.
Resistive, ma'am.
Resistive. So potentiometer is a resistive transducer or not a resistive transducer?
Resistive transducer.
So this is a resistive transducer and it is a passive transducer. Okay. Sometimes they might ask you this question in MCQ. Okay. So that's why I'm telling you this is a resistive passive transducer. Okay, and electrical transducer. Now, simple terms or shorthand form, it is called a spot, and it makes use of the principle of voltage division, and it is a variable resistor or a fixed resistor arrangement.
Variable.
Variable resistor. Okay, it's a variable resistor arrangement, and it is based upon its operation is based upon voltage division, and it is a passive electronic transducer. Okay, now we'll see to the picture. So this is how a potentiometer will look like. So this is relying upon the input voltage or not?
Yes, ma'am.
Yes. So that is why it is called as a passive
Passive.
transducer. So this is your variable resistor arrangement or a fixed resistor arrangement?
Variable.
Variable. How does that variation happen? There is a tapping arrangement here which is called as a slider. Okay. So if you are able to vary the slider across this resistance, you will be able to get a variation in resistance. So you just input some voltage to the fixed end and you vary the sliding contact, you will be able to get a variation in the output voltage. Okay, so this is how the potentiometer works. Okay, on the basis of voltage division by adjusting the flow of current through the resistance, you are able to achieve this conversion. Okay, using the resistive effect only, that variable is being converted into an electrical signal. Which is the electrical signal here? Output
Output voltage.
voltage. So voltage is the electrical signal to which the physical variable will be converted. Okay, so this is how a potentiometer works. So there are two types of potentiometers actually, rotary one and linear one. Both the principle of operation is same. Okay, and there are three terminals actually. One will be the wiper terminal, that is slider contact. By varying this wiper only, you will be able to vary the fixed resistance to a variable resistance, and you will be able to vary the output voltage drop. So while you are giving this connection to the circuit, one end you will leave it free and the remaining two ends you will use. Okay, this one is rotary and this one is linear. Okay, so two types of potentiometers are there. And these are the applications of potentiometer they have mentioned here. So a battery cell, if you are assuming if you want to measure the voltage of the battery cell, then you can use a potentiometer. Okay, suppose if you want to measure the internal resistance of the battery, you can use a potentiometer. Generally, if you want to measure any voltage in a circuit, then you can use this potentiometer. Okay, so that's all about potentiometer. Using this potentiometer, another device is also there, that is called as force summer. Now we'll discuss the force summer. Diagram I will draw. Wait. Okay, this is also a transducer called as force summing device. So are you able to observe the potentiometer? Is there any potentiometer used in this arrangement or not? Is there any potentiometer arrangement or not?
Yes.
Yes, ma'am.
Where this one, this is your output voltage. This one is your wiper or slider. Okay, and this one is your watt. Okay.
Very
So
well.
what is a physical variable that you are going to measure here?
Force.
Force or pressure. So there is an input pressure port. So you will apply force here or pressure. So what will happen? This is your force summing device. Okay, this is your force summer. So you are applying force to the force summer. So that will get displaced. Okay, that force summing device will get displaced, and that displacement will cause what to the wiper? The
Displacement.
wiper will move or not?
Yes, ma'am. Yes, ma'am.
Yes, the wiper will move. Okay, according to the moment of the wiper, what will get varied?
Resistance.
Resistance will get varied. Then, as a resultant of which, what will be varied?
Voltage.
Voltage. Okay, so what is being converted to what here? What type of transducer is this force summer? Active or passive, electrical or non-electrical, displacement or non-displacement, resistive or capacitive or inductive. Which one? Again, I am telling you, you are going to apply a force or a pressure onto the input port. So with the application of the pressure, the force summer will get displaced. And with this displacement, there is a wiper or slider here that will move, okay, over this resistance, because of which there will be a variation in this resistance, and across these contacts there will be a variation in the output voltage. So this arrangement is called as force summing device. So tell me what category it will belong, resistive or inductive or capacitive? Which one?
Resistive.
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 Okay. And passive or active?
Passive.
Passive. Passive.
Passive, because there is an input voltage, so it's a passive type. Displacement or not displacement?
Displacement.
Displacement. Okay. And next, electrical or non-electrical?
Electrical.
Electrical, because the input that you are going to measure is force and the output is electrical
Electricity.
signal voltage. So this will be an electrical transducer. What is the name of the transducer? Force
Force.
summer.
Summer. Transducer.
Okay, force summing device or force summer that converts the given pressure or force to an equivalent electrical voltage with the help of the potentiometer. It takes place. Okay. So this is also another type of resistive transducer. Right. One more LED will finish. Can you tell me any example for optical type of transducers? What are optical transducers?
Light into electrical.
Ma'am, photoelectric
Light.
will be optical
Any
only.
example can you give?
Photodiode.
Photodiode. How it is optical?
Hmm.
What is optical effect? Wait, let me load up that LED. Okay. Next, we'll discuss optical transducers. So you people understood capacitive transducer, inductive transducer, resistive transducer. You understood?
Yes, ma'am.
So what are the examples for resistive transducer today we discussed? Two
Force.
types we discussed. No? One is strain gauge, okay, that measures the input force strain into resistance. What are the types of strain gauge that we discussed?
Bonded and bonded.
Bonded and bonded, depending upon whether the material under study is bonded to that strain gauge with the help of an adhesive or not. Okay, it is distinguished into bonded and unbonded. Okay, and one more type of resistive transducer. What type did we discuss? Potentiometer. Okay, next we'll discuss LED, optical type of transducers. Thermometer, thermistor and all, what type of transducer? Thermometer, thermistor,
Electrical.
what will the temperature transducer do?
Converts temperature into electrical signal. Means heat temperature.
Example for the thermal transducer is what? Good example, simple example is your
Meter.
thermometer. Okay,
Yes.
all must be familiar with thermometer, I think so.
Yes. Ma'am.
Similarly, so many other types of thermal transducers are also there. Okay, that we'll discuss. RTD is there, so many other types. Okay. Now we'll discuss photoelectric transducers. So I have listed out some devices. Okay, so what will it do? Laser diode, LED, that is light emitting diode. What do they do? What type of energy conversion happens there?
Electrical to light.
Okay, electrical power you will be giving it as input and the output will be light energy. Okay, so electrical to light energy. Okay, and then what about photodiode, photoresistor, phototransistor, photomultiplier? What conversion of energy happens?
Light to electrical.
Light to electrical. So both these category are called as what type of transducer?
Photoelectric transistors.
Photoelectric transducer. Okay. So remember the examples. When you take LED or laser diode, the input electrical energy will be converted into a light. Okay. But if you take the case of photodiode, phototransistor, photo multiplier or solar cell in general, what happens in a solar cell? What is
It
the input and
converts
what is output?
light into
Yeah.
electrical form.
Sunlight falls on the solar cell, which will be converted into an equivalent electrical energy. So those type of transducers will be called combinedly as photoelectric transducer. Okay, I'll discuss one by one, starting with the LED. So again, LED, what type of energy conversion? Electrical to light. Okay, so how that action happens? Anybody can tell me? Ordinary PN junction diode we have learned, we have studied in the earlier class. Okay. How does it differ from a light emitting diode? All must have seen LED now.
Yes, ma'am.
So how does it differ from an ordinary PN junction diode? Ordinary PN junction diode means you will be using only two types of semiconductor, silicon or germanium. Okay, but when it comes to LED, are you using the same silicon, germanium or any other material?
Ma'am, doped on.
Doped only, but tell me whether it is the same silicon germanium content that will be present inside an LED or different. You also have observed that LED is not only giving white light, it is also capable of giving different colors of light. What are the different colors that it gives?
Red, blue, green, white.
Yes. How is that different color combinations is possible?
Change in
Is it?
composition of cell.
Yes, composition of the inner semiconductor material, but is it silicon or germanium? That is the question.
No, ma'am.
No, it is not silicon germanium because silicon germanium will be having low energy barrier. So you cannot use silicon germanium here for light emitting effect. You have to go for a different type of material. All right. You will be using gallium nitride. Okay. Gallium nitride arsenide. So depending upon what material you are going to use, the color will differ. Okay, suppose if you want to pick one red color means one type of material you use. If you want to use blue color means that material you have to use. And in saying so, it doesn't use silicon or germanium similar to a PN junction. It is using a different types of material like gallium arsenide, gallium nitride arsenide. Okay, depending upon the material that you pick, the colors will be visible, different. And plus, how that light emission happens.
And when electrons get energy from valence band to conduction band.
Yes, when you are giving electrical energy to the LED will be forward biased. Okay, so the electrons will be getting excited. It will be jumping from valence band to conduction band. Okay,
Yes, ma'am.
then when they lose their energy, they will fall down. Okay, when they lose their energy, it will fall down. When they fall down from the energy loss, it will emit photons of light. Okay, those photons of light is the output light energy that you are observing. So this is how an LED works. Okay, so if you see to the construction here also, you will be having a cathode and an anode combination. Longer leg will be anode and the shorter leg will be cathode, and you will be having an encapsulation, visible encapsulation, so that it gets protected. So just you are going to apply the biasing condition to this. Okay, so plus minus. So this is a light emitting diode you observe, LED. So let this be the anode, let this be the cathode. So forward bias you are making. Okay, so because of which the output will be emission of light, photons of light. All right, normal diode you will symbolize like this. LED means you will symbolize with these rays. Okay, these rays are photons of light, which is visible light energy that you get as output from LED. Okay, so this is how input light energy is being converted into what's the output? What is the output that you are getting from an LED? What is the input?
Like
Ma'am,
Input
electrical.
is electrical signal, which will be converted into output, that is light energy. And how that happens? When you are giving electrical energy, the excited electrons will jump from valence band to conduction band. When they lose their energy, they will fall down. Okay, when they are falling down, they will emit what?
Photons.
Photons of light. Okay, which is nothing but output light energy. So this is how it is coming under photoelectric type of transducer. Okay. And there is another category of division also under photoelectric transducer: photoconductive, photovoltaic, photoemissive. Okay. LDR I have to discuss, but that is requiring so much amount of time, so I won't do it now. Photodiode or solar cell, how does it work? Photodiode or solar cell. These are some examples for photoconductive device. Okay, and why it is called as photoconductive is because when you are applying light onto it, with the change in the light intensity, the resistance will change. That is why they are called photoconductive or photoresistive transducer. So what examples are coming under photoconductive or photoresistive transducer? What examples are given? Photoconductive transducer means what examples are given?
Light dependent transistor.
Light dependent resistor, photo transistor, then
Photo.
photodiode.
Photodiode.
So why are these called as photoconductive? are photoresistive transducers. All these will be converting what to what? LED means it converts electrical to light.
Light
These
to
devices will convert
electrical.
Light
light to
to
electrical energy. So
electrical.
all these, including solar cell also. Solar cell is sometimes called as photodiode. Okay. So all these devices you are going to input sunlight or any other light. Okay. Light intensity when it varies, accordingly what will change?
Resistance.
Resistance. Okay. With the resistance change, you will be able to change the electrical output signal also. So this is why they are all called as photoconductive transducer. The description of all these things we'll discuss in the next class. Okay. All right. So many types of photoelectric transducers we have to discuss that I will cover up in my next class. Okay. Since LED is coming in our earlier unit, I wanted to finish. Okay. Now all can disperse.
Thank you,
Thank you,
ma'am.
ma'am.
Okay, ma.
Thank you, ma'am.
Okay, ma.
Thank you, ma'am.
Okay, ma.
Thank you, ma'am.
Hello.
Ma'am, can we leave now?
Yes, yes. All can leave. I told you, no.
Ma'am,
Thank you, ma'am.
What?
ma'am, can you extend the date for wiring experiment?
What wiring?
Ma'am, experiment.
Staircase.
Yeah, not high staircase experiment.
Staircase, I already deleted. There is a
No.
video put up, no, for it.
Yeah.
You did not
But
understand.
no, can you extend it? Because
You
it is
want me
for
to
9.
explain the E-circuit
No.
part or what?
I am
Ma'am, he
saying,
wants to extend the due date.
yeah, extend the due date.
Due date.
Ma'am, it's
See, I
9th of
already
December.
told you your exam is coming up by 5. I am supposed to take the average of the next 4 experiments and I am
Ma'am, we will
supposed to
submit
enter
after
mark.
10th, na, 11th or 12th.
When
Because
will I correct? And when will the people already submitted the remaining 3 experiments? What are
yeah,
the experiments that you submitted already?
that
Ma'am, we have submitted till this one. Wave shapers not.
wave shaper
Atom
rectifier,
DC and AC machines.
DC and AC
DC,
machine.
AC machines you submitted. Then BJT characteristics PN junction
Yeah,
diode you
Yes,
submitted.
yes, ma'am.
yeah,
Yes,
ma'am.
ma'am, already.
And then 1, 2 more.
And one more that
Wave shapers you submitted.
yeah, wave shaper too.
Then one more experiment you have to submit. Otherwise, I
Ma'am,
can't
can we
take
do
the
after
4 experiment average.
10th?
Huh?
Ma'am,
That
after
means last one.
after CT, ma'am. Ma'am, now
After
sites
CT,
are not working.
4 experiments I have to take average. Okay, not
Now
3,
site is
4.
also not working, na e-circuit side.
Staircase wiring is easy only. Why you people are feeling difficulty when you can complete wave shapers and all? What is the difficulty for you to complete
Ma'am,
staircase?
because we have 7 experiments and the due date for this is 7 or 8 between our CTs.
I have given 1 month time, no man. I was tolerant for late admission people 1 month for first
Ma'am,
CA
and
component.
Only 2 days, ma'am, please.
So I am supposed to
Only 2
take
days,
the
ma'am.
average of 4 experiments. I want 4 experiments submitted from your side.
excuse
Okay.
me, ma'am.
Hmm.
Ma'am, we have to write that fluorescent lamp part also now in
Fluorescent
this
lamp you have
statement.
to write, yes. Demo video I will make it later when I am free.
Okay, ma'am. Okay, okay. Thank you, ma'am.
So you have to do it as an assignment. Okay. If what is the due date that you want me to set for that experiment?
Ma'am, after 10th.
After 10, after 10
Yeah,
I
ma'am.
won't set it. 10 means okay.
Ma'am, because we have no exam on
So I
10th.
have to correct, man. 57 online submissions I have to check, no, man.
Ma'am,
Okay,
and
the
how to
more
submit
delay
this
you
circuit
make,
part?
the more effort I have to put. I will take the accumulation of results. Then I have to check who has not submitted. Then I have to check them. I have to tell them to submit. Okay, if you are doing it late, then all these things will take place late. Okay, so better do it before 10.
Okay, ma'am.
Ma'am, how you have to post that means e-circuit part in Word we have to paste
Yeah,
and
copy and
then
submit. Yes.
okay, okay, ma'am.
Okay, ma'am. Sorry, but I am also busy now. I can't push the deadline to the last minute. Okay.
Okay.
Okay. Thank you.